Alright, Chapter 2, Bridge Structure. Definition. For the purpose of the span with the bridge, defined with the structure, including support for the erected over the depression of the construction, such as the water, highway, railway, or having the truck or the passageway with the carrying the traffic, other moving load, than having the opening measure along the span of the roadway more than 20 feet between the under opening of the abutments of the spring lobe of the brae arch of the extreme ends of opening of multiple boxes. It may also include the multiple pipes where clear distance between the opening is less than one half of the smaller continuous opening. 2.2. Classification. Inspector must be aware of the bridge type of the properly designed of the bridge for the inspection report. The main emphasis of the description should be the main span of the bridge is class according with their function with the structural type of the structural material. The functioning of the bridge refers to the current improved classification roadway. Some of the typical roadway classifications are an interstate with the freeway with the principal arterial, mineral, arterial, collector, major, minor, military, etc. Structural type. The type of the bridge is defined by structural frame system and the type of the substructure. Structural framing subsystem. The basic of the four system, the structural framing system with a simple span, the continuous span with the cantilever and the suspended span, rigid frame. They are described as the following: a single span with the span consisting of the substructure with the spanning with a single unrestrained bearing at each end. The support must be such that they allow the rotation of the span flexes under the load, ordering at least one support with attached within the way of the keep of the span from longitudinally. Figure 2.1, Part A, to demonstrate the simple span. To be a continuous span. A span considered with a continuous speech with a graph of the three or more supports. Figure 2.1 Part B show with the two-span continuous structure. The note that the support of the end of the continuous unit or the similar of the end of the simple span with the however the beak of the member of the continuous over the center support with the magnitude of the member of the rotation restricted to the area adjacent to the pier with the bridge of the may be continued with the over many of the support with a similar rotational character for the over even the anterior support with the cantilever and suspended span. Sometimes the advantage of the structural standing point of the continuing span over the pier with the terminal near the pier with the cantilever. The cantilever is ordinarily with the support with the suspended with the end of the adjacent span with the arrangement shown in figure 2.1. Part C with the other end of the suspended span. Mainly in some of the cases, the support and another cantilever may be rest on the ordinary simple support. Rigid frame. The frequently used with the transverse support with the steel construction or occasionally used with this longitudinal span with the term the rigid that derive of the manner of the construction fabrication which does not allow the relative rotation between the members of the joint. The rigid frame may be rigidly attached to the base fixed and may be simply supported. Substructure. The various type of the substructure, the slab of the truss with the garage girder arch is in suspension not covered in the span. The beam girder with the string or the composite. The structural material, the basic type of the structural material, the steel, the concrete, timber, the stone, the masonry, wrought iron, cast iron, and aluminum. Figure type 3 typical bridges based upon the above classification criteria. The typical bridges can be defined and are summarized in figure 2.3 through 2.5. Block culverts. Block culverts range inside from small single cell with a unit to multi-cell unit. The largest 20 by 20 feet. Natural rock with which present may be with the floor of the box culvert is usually clothed with a rectangular frame with the transverse joints are provided early to 20 and 30 feet. Occasionally, old culverts consist of a simple slab on the wall. These are non-true box culverts. Some of these slabs are made of stone, while some of the walls are made of rubber and masonry rather than concrete. 2.5 Military bridge. The large variety of the special purpose military bridge for the bridge for the most part with the design for the expedient deployment under the combat situation that are not intended for continued day-to-day use of the civilian military traffic. However, the economic constraints of some of these bridges are stricter than permanent structures on some military installation. Therefore, the bridges and maintenance of the repair of the bridges must also be addressed. Some of the type of the military bridges are shown in figure 2.6 through 2.10. And then we'll go over 2.6 and 2.10. Alright, this is your simple beam with loads on the tension, and then the tension loads and bolted splices, continuous spans. Alright, this is a pin hanger, loads and tension, seated span, loaded span. So you have your bolted splice, your pin hanger, and your seated span, okay? And that is your structural framing. B is continuous span, A is a simple beam, continuous span, beam, and then it's cantilever suspended span, beam. Beams, structural frame support. Alright, this is the through Howe truss, through part of the part of Pratt truss, which is double X in the middle, moving to the outside through Warren housing, quadrilateral through off Warren housing. That's X's through Whipple truss, Trussell and Camelback truss, through Baltimore truss and K truss. And then you have your thorough truss and pony truss and deck truss, cantilever truss bridges and steel timber constructions, and this would be a static Vatic, thorough arc truss, rigid frame steel, frame steel girder element, throw girder, deck girder, and I-beam. Continuous girder, spiral-filled arch, open spandrel arch, rigid frame concrete. Your rigid frame concrete slab section and T-beam section concrete T-beam section. Roadway section box girder, reinforced concrete bridges, figure 2-4, timber trestle, pile bent, frame bent, and then it shows a picture of your rail Bailey bridge using a belly panel piers. And then this one would be a double Bailey bridge, your T6 aluminum fixed bridge, a class 50 M4 trestle bridge aluminum, and this one is a timber trestle. Chapter 3 Bridge Elements.